Hi everyone, I am Miss Jarina. Welcome to St. John's International IGCSE Chemistry Seminar 2021. In this video, we will look about assessment overview, content overview, subject content, practice questions, and glossary of terms used. I have also added a few videos related to planning and preparation. Let's start with assessment overview. All candidates take 3 papers. Candidates who have studied the core subject content will be entered for paper 1, paper 3, and paper 6. These candidates will be eligible for grades C to G. Candidates who have studied the extended subject content will be entered for paper 2, paper 4, and paper 6. These candidates will be eligible for grades A star to G. Let's start with paper 1 or 2. Paper 1 or 2 is for 45 minutes. It is a multiple choice question consisting of 40 items of the 4 choice type. The number of marks for this paper is 40, but this paper carries 30% of the final total mark. A general tip for paper 1 or 2. While choosing the answer, use a pencil to cross out the choices that are clearly incorrect. Then choose between the others. This will help you to minimize errors and also to save time. Paper 3 or 4, 1 hour, 15 minutes. This is a written paper consisting of short answer and structured question. The number of marks for this paper is 80. This paper carries 50% of the final total mark. Here are some general tips for paper 3 or 4. Read the question correctly. For example, if the question says give 2 observations apart from temperature change, don't include temperature change in your answer. In any calculation, the final answer should be the correct number of significant figures, generally the same as given in the question. You may be penalized if you write an excess number of significant figures. Example, 1.257487 instead of just 1.26. Avoid vague statements. For example, if the question asks about the use of graphite, the answer should be, graphite is used for electrodes in electrolysis. Graphite is used in electrolysis is a very vague answer. Paper 6 is for 1 hour. This is alternative to practical, and the questions will be based on experimental skills. The number of marks for this paper is 40. This paper carries 20% of the final total marks. Some general tips for answering paper 6. Check for contradictions within your answer. For example, a common error is to write a white insoluble precipitate dissolves when the question is about testing for ions. When drawing diagrams, make sure they fill the space given on the paper and are labeled. When drawing apparatus for gas measurement, make sure that the gas cannot escape. For example, don't draw a gas syringe with the plunger much smaller than the syringe. When drawing graphs, students should use a sharp pencil for plotting points and for drawing the lines of best fit. This allows you to correct any errors. The line of best fit might be a curve or a straight line. Straight lines should be drawn with a ruler, but rulers should not be used to join the points on a curve. Lines of best fit should avoid anomalous points. Moving on, let's look at content overview. All candidates study the following topics, irrespective of core or extended. 1. The particulate nature of matter, experimental techniques, atoms, elements, and compounds, stoichiometry, electricity and chemistry, chemical energetics, chemical reactions, acids, bases, and salts, the periodic table, metals, air and water, sulfur, carbonates, and organic chemistry. Before moving on to the next part, let us watch a video on learning. The study tips mentioned in the video are easy to follow and well done to those who already have a plan. Now moving on, let us look at areas to concentrate. Now the areas to concentrate are based on the chemistry syllabus 0620. Now let's start with the particulate nature of matter. Describe the properties and structure of solids, liquids, and gases. Explain changes of state in terms of the kinetic theory. Describe and explain Brownian motion. Describe and explain dependence of rate of diffusion on molecular mass. Experimental techniques. You're expected to name appropriate apparatus for the measurement of time, temperature, mass, and volume. Interpret simple chromatograms. Outline how chromatography techniques can be applied to colorless substances. Describe and explain methods of purification. Suggest suitable purification techniques such as filtration, distillation, etc., given information about the substances involved. Atoms, elements, and compounds. State the relative charges and approximate relative masses of protons, neutrons, and electrons. Define proton number, define nucleon number, define isotopes. State the two types of isotopes as being radioactive and non-radioactive. State one medical and one industrial use of radioactive isotopes. Describe the differences between elements, mixtures, and compounds, and between metals and non-metals. Describe alloys such as brass as a mixture of a metal with other elements. Describe the formation of ionic bonds between metallic and non-metallic elements. Describe the electron arrangement of covalent molecules such as nitrogen, ethene, methanol, and carbon dioxide. Explain the differences in melting point and boiling point of ionic and covalent compounds in terms of attractive forces. Describe the macromolecular structure of silicon 4 oxide. Describe the similarity in properties between diamond and silicon 4 oxide related to their structures. Describe metallic bonding as a lattice of positive ions in a sea of electrons and use this to describe the electrical conductivity and malleability of metals. Stoichiometry. In stoichiometry, you have to know how to determine the formula of an ionic compound from the charges on the ions present. Construct equations with state symbols, including ionic equations. Deduce the balance equation for a chemical reaction. Define the mole and the Avogadro constant. Calculate stoichiometric reacting masses, volumes of gases and solutions, and concentrations of solutions expressed in gram per decimeter cubed and mole per decimeter cubed. Calculations involving the idea of limiting reactants may be set for extended students. Calculate empirical formula and molecular formula. Calculate percentage yield and percentage purity. Let us practice a question on chemical calculation. Calcium chloride can be made by reacting calcium carbonate with hydrochloric acid. Calcium carbonate plus hydrochloric acid forms calcium chloride plus water plus carbon dioxide. An excess of calcium carbonate was added to 50 centimeter cube of 0.5 mole per decimeter cube hydrochloric acid. The solution was filtered to remove the excess calcium carbonate. A. How many moles of hydrochloric acid were used in this reaction? Now here you need to use the formula to calculate moles for solution. The formula is concentration times volume divided by 1000. Concentration is 0.5 and volume is 50 centimeter cube. So you have to divide it by 1000 to convert it to decimeter cube. And when you find the answer, it is 0.025 mole. Now B, deduce the number of moles of carbon dioxide gas made in this reaction. Now over here, we are unable to use the formula to calculate the number of moles of carbon dioxide. So we have to look at the equation and use the ratio method. Now, according to the equation or from the equation, we know that 2 moles of hydrochloric acid produce 1 mole of carbon dioxide gas. So the ratio is 2 to 1. The number of moles of hydrochloric acid is already calculated, which is 0.025. So when you divide it by 2, it's 0.0125, and that is the number of moles of carbon dioxide gas that is made. Okay, moving on C, calculate the mass of carbon dioxide made in this reaction. Now mass is equal to mole times molar mass. Since we already know the moles of carbon dioxide made, we need to calculate the molar mass of carbon dioxide by using the relative masses in the periodic table, and you get your answer as 0.55 grams. D, calculate the volume in decimeter cube of carbon dioxide made in this reaction at room temperature and pressure. Formula to calculate volume of gases is equal to mole times molar volume. Mole has already been calculated. Molar volume of a gas in decimeter cubed is 24. So the answer becomes 0.3 decimeter cubed. Questions based on calculations are commonly present in the IGCSE exams. Hope students can answer them well and get all your answers correct. Moving on, electricity and chemistry. In electricity and chemistry, students are expected to relate the products of electrolysis to the electrolyte and electrodes used. Describe electrolysis in terms of the ions present. Predict the products of electrolysis. Construct ionic half equations for reactions at the cathode. Describe the production of electrical energy from simple cells, that is, two electrodes in an electrolyte. You need to describe in outline the manufacture of aluminum from pure aluminum oxide in molten cryolite, the electrolysis of brine, where you get chlorine, hydrogen, and sodium hydroxide from concentrated aqueous sodium chloride. Moving on, chemical energetics. Describe bond breaking as an endothermic process and bond forming as an exothermic process. Draw and label energy level diagrams for exothermic and endothermic reactions using data provided. Calculate the energy of a reaction using bond energies. Describe the use of hydrogen as a fuel reacting with oxygen to generate electricity in a fuel cell. Devise and evaluate a suitable method for investigating the effect of a given variable on the rate of a reaction. Describe and explain the effects of temperature and concentration in terms of collisions between reacting particles. Describe and explain the role of light in photochemical reactions and the effect of light on the rate of these reactions. Predict the effect of changing the conditions on other reversible reactions. Demonstrate knowledge and understanding of the concept of equilibrium. Define redox in terms of electron transfer. Identify redox reactions by changes in oxidation state and by the color changes involved when using acidified potassium manganate 7 and potassium iodide. Define oxidizing agent as a substance which oxidizes another substance during a redox reaction. Define reducing agent as a substance which reduces another substance during a redox reaction. Identify oxidizing agents and reducing agents from simple equations. Before moving on to the next part, let us watch a video on how to collect gases in a reaction. That video showed you how to collect a small volume of gas in a test tube. Moving on, let's look at acids, bases, and salts. Now, in this topic, you're expected to define acids and bases in terms of proton transfer limited to aqueous solutions. Describe the meaning of weak and strong acids and bases. Classify oxides as acidic, basic, amphoteric, and neutral. Demonstrate knowledge and understanding of the preparation or demonstrate knowledge and understanding of the preparation of insoluble salts by precipitation. Suggest a method of making a given salt from a suitable starting material given appropriate information. Identification of ions and gases. The periodic table. Describe and explain the relationship between group number of outer shell electrons, and metallic or non-metallic character. Identify trends in groups given information about the elements concerned. Know that transition elements have variable oxidation states. Metals. Describe the reactivity series as related to the tendency of a metal to form its positive ion, illustrated by its reactions with the aqueous ions, the oxides. Describe and explain the action of heat on the hydroxides, carbonates, and the nitrates of the listed metals. Account for the apparent unreactivity of aluminum in terms of the oxide layer which adheres to the metal. Describe in outline the extraction of zinc from zinc blende. Explain the uses of zinc for galvanizing and for making brass. Describe the idea of changing the properties of iron by the controlled use of additives to form steel alloys. Air and water. Discuss the implication of an inadequate supply of water. Describe the separation of oxygen and nitrogen from liquid air by fractional distillation. Describe and explain the presence of oxides of nitrogen in car engines and their catalytic removal. Describe and explain sacrificial protection in terms of the reactivity series of metals and galvanizing as a method of rust prevention. Describe and explain the essential conditions for the manufacture of ammonia by the Haber process. Describe the carbon cycle in simple terms to include the process of combustion, respiration, and photosynthesis. Sulfur. Describe the manufacture of sulfuric acid by the contact process, including essential conditions and reactions. Describe the properties and uses of dilute and concentrated sulfuric acid. Carbonates. Describe the manufacture of lime, calcium oxide from calcium carbonate, limestone, in terms of thermal decomposition. Name some uses of lime and slaked lime, such as in treating acidic soil and utilizing acidic industrial waste products. Example, flue gas desulfurization. Name the uses of calcium carbonate in the manufacture of iron and cement. Practice question 2. Solid copper 2 carbonate undergoes thermal decomposition. One of the products of the thermal decomposition is copper 2 oxide. State the color change of the green solid seen during the reaction. Start color green. Start color is green because solid copper 2 carbonate is green in color. So that is the reactant here. Now when copper carbonate undergoes decomposition, it forms copper oxide. Copper oxide is one of the products, and copper oxide is black in color. So N color is black. Write a chemical equation for the thermal decomposition of copper 2 carbonate. So copper 2 carbonate, when it decomposes, forms copper oxide and carbon dioxide. Remember, when you are asked to write a chemical equation, do not write a word equation. And all chemical equations have to be balanced. Copper 2 carbonate reacts with dilute nitric acid. One of the products of the reaction is a solution of copper 2 nitrate. Describe tests for copper 2 ions and nitrate ions. Include the results of the test. Copper 2 ions. Add a few drops of sodium hydroxide solution. This is the test. The result is a blue precipitate is formed. Nitrate ions. The test is Add aqueous sodium hydroxide, then aluminum foil, and warm carefully. Ammonia gas is formed. And the result is ammonia gas turns damp red litmus paper to blue. Questions based on the testing of ions is commonly asked. Students are advised to learn the testing of positive ions and negative ions. Organic chemistry. In organic chemistry, you have to name and draw the structures of the unbranched alkanes, alkenes, alcohols, and acids containing up to 4 carbon atoms per molecule. You have to name and draw the structural formula of the esters, which can be made from unbranched alcohols and carboxylic acids, each containing up to 4 carbon atoms. Describe petroleum as a mixture of hydrocarbons and its separation into useful fractions by fractional distillation. Describe the properties of molecules within a fraction. Name the uses of the fractions. Describe the general characteristics of a homologous series. Recall that the compounds in a homologous series have the same general formula. Describe and identify structural isomerism. Describe substitution reactions of alkanes with chlorine. Describe the properties of alkenes in terms of addition reactions with bromine, hydrogen, and steam. Outline the advantages and disadvantages of the two methods of manufacturing ethanol. Describe the formation of ethanoic acid by the oxidation of ethanol with acidified potassium manganate 7. Describe ethanoic acid as a typical weak acid. Describe the reaction of a carboxylic acid with an alcohol in the presence of a catalyst to give an ester. Understand that different polymers have different units or different linkages. Moving on. Students have to explain the differences between condensation and addition polymerization, deduce the structure of the polymer product from a given alkene and vice versa. Describe the formation of nylon, a polyamide, and terylene, a polyester, by condensation polymerization. Structure of nylon and terylene. Proteins and carbohydrates. Describe proteins as possessing the same amide linkages as nylon, but with different units. Describe the hydrolysis of proteins to amino acids. Describe complex carbohydrates in terms of many sugar units joined together by condensation polymerization. Describe the hydrolysis of complex carbohydrates, example starch, by acids or enzymes to give simple sugars. Fermentation and chromatography. Describe the fermentation of simple sugars to produce ethanol and carbon dioxide. Describe in outline the usefulness of chromatography in separating and identifying the products of hydrolysis of carbohydrates and proteins. It's time for the next question. Now, nylon, terylene, and proteins are all polymers. What is a polymer? A polymer is a large molecule made from many small molecules called monomers joined together. The number of marks is 2. So you need to answer according to the marks that are given. Proteins are natural polymers. Proteins are biodegradable. Name the type of linkage in proteins, amide or peptide linkage. What is meant by the term biodegradable? Biodegradable means can be broken down by microorganisms or by bacteria. Name another natural polymer, starch, cellulose, or DNA. Be careful not to write proteins because proteins is already mentioned in the question. Glossary of terms used. Before we continue with the glossary of terms, let's take a look at another short video. That video was about the thermal decomposition of copper to carbonate. You could clearly see how the green copper to carbonate decomposed to form black copper to oxide. Okay, moving on. There are a number of instructions that appear on examination papers, and candidates should be very clear of what they mean. Here are some of the common instructions. When a question says define, just a statement or definition is required. State, just a short answer is required with little or no supporting argument. List requires a number of points, generally each of one word with no elaboration. Where a given number of points is specified, this should not be exceeded. If you're asked to write 5 properties or 5 points, just write 5. Explain. It is another way of asking candidates to give reasons. The candidate needs to clearly give reason as to why something happens. State and explain. Again, a short answer is required with reasons. Deduce means calculate, measure, etc. Calculate, a numerical answer is required. You should show your working as well as your answer. Do not forget to put in the correct units. Describe. Describe requires the candidates to state in words using diagrams where appropriate the main points. Describe and explain may be coupled, as may state and explain. Discuss requires the candidate to give a critical account of the points involved. Outline. The answer must be brief and the main points must be written. Predict. You're not expected to recall the answer, but to link other pieces of information together logically to work out an answer. In conclusion, I have discussed with you the syllabus content and some tips and tricks on how to prepare yourselves for the coming IGCSE chemistry exams. Revision is more than just sitting down and reading through a book. It is important to have a plan. Set yourselves a definite revision targets to complete certain sections by a certain date and make sure you achieve them. Hope you find this video useful and I wish you luck in your exams. If you have any questions or want additional information, please feel free to contact me. All the best. Thank you.